rahmatullahi wa barakatuh. Here Mrs. Houda Dalibalta, and as I promised you, dear grade 11 students, in these videos, we are going to talk about derivatives. We are going to have training exercises on derivatives, including several rules we know, including the domain of definition of a function and that of its derivative and comparison between them. Now, in these exercises, let's make like a summary for the rules. We are going to use the rules you all know. So let's make like a little revision for these rules. All of you know that if we have a function in the form of kx and I need to find its derivative, the answer is k. So I'm talking about the rules of derivatives and not the derivative by using the definition. So in general, if a function is in the form of kx, then its derivative is just that constant multiplied by x. Now, if I have a constant alone, so a function is about a constant, then its derivative is definitely 0. Now, let's remember the most famous rule for derivatives. It is x power n prime. If the function is in the form of x power n and I need to find its derivative, it is n into x to the power n minus 1. Now, if I have it in the form of kx power n, if it's a constant multiplied by x raised to a certain power, then the derivative is k times that n times x raised to the power n minus 1. Now, what if I have 1 over x? 1 over x, if I want to find the derivative of that one, I can write it in the form of x power minus 1, and I can apply that rule on it, which is n times x n minus 1, and definitely I'm going to get the answer, which is minus 1 over x squared. So if we just apply the rule here, we are going to multiply by the power, which is minus 1. Then x power minus 1 is power minus 2, and definitely we get minus 1 over x squared. Similarly, if I have to find the derivative of radical x is indeed as x raised to the power half. So if I need to find the derivative of x power half, I need to multiply by that power and to make it x to the power minus half, then definitely it is equal, the derivative of that function is equal to 1 over 2 radical x. So we can directly use this rule and this rule, okay, for 1 over x and radical x. Now, what happens if I have a function in the form of u dot v? It's not just x or a simple x, it's just like a complex. So u dot v, the derivative is u prime v. Now, I'm just reminding you of rules, plus v prime u, and according to the function of the form u over v, its derivative is u prime v. Of course, you remember these rules. U prime v minus v prime u over v squared. So these are the rules that you are going to face to use, and sometimes you may need to use that rule. For example, if I need to find the derivative of radical u, it is just u prime. It looks like radical x, but there is not a simple x inside the radical. U prime over 2 radical u, and if I have the function in the form of u to the power n, then its derivative is n multiplied by u prime multiplied by u raised to the power n minus 1. And after reviewing the rules, let's get started. And here are the flowers for you to let you like optimistic, to let you enjoy these videos, inshallah. Let's start by the first example. Now this function here is f of x, that's equal to x cubed minus 4x to the power 5 plus 3 over x plus 5. That function is not a polynomial because the power of x, if we raise it, it is like x raised to the power minus 1, and by definition of a polynomial, all of the powers on the monomials must be natural numbers. So that's not a polynomial, then the domain of definition is not gonna be R. Now let's find the derivative of f of x, applying the rules, and then we'll talk about the domain of definition. So let's get started. F prime of x is equal, as I told you, we put 3 here, then we decrease the power by one, so we'll get 3x squared. Minus 4 is the constant, so we keep it. So we can make the derivative of each term alone. This alone, and this alone, and etc. Okay, so 3x squared comes from the rule nx n power minus 1. Minus 4, we keep it. We put the power here, and then we decrease it by 1 to get 4. Now 3 over x is exactly like 3 multiplied by 1 over x. So we keep the constant 3 as you see here, and we make the derivative for 1 over x, which is minus 1 over x squared, and that will go to 0 because it's a constant, and as I mentioned, the derivative of a constant is 0. So finally we are going to get 3x squared minus 20x to the power 4 and minus 3 over x squared. Now let's talk about the domain of definition. As I told you, because we have x here in the denominator, then the condition on x is that it should not be equal to 0. So the domain of definition of this function f is r minus 0, so it's written as minus infinity 0 union 0 plus infinity and opened at 0 as you see here. Also, the domain of definition of its derivative is the same because again there is an x in the denominator, so the condition is on x squared, that should not be 0, then x definitely should not be 0, and so the domain of definition of f prime is also r minus 0 as this one. So that's about the first example. Here we go with the second example. Now in this example we have a function that's equal to minus 3x to the power 6, f of x equals that, plus 7x squared minus 4 radical x and minus 8. So again, we have to make the derivative of each term, and again, this is not a polynomial, so its domain of definition is not R also. The domain of definition is going to be based on that because we have radical x, and the condition is that x should be greater or equal to 0, and we're going to mention it after finding the derivative. So we keep in mind that there is a condition here for x should be greater or equal to 0 because it's put under a radical. Now let's continue. F prime of x, again we put the constant as it is, we put the power and we decrease it by 1, so we get minus 3 into 6 into x to the power 5. Again we keep the constant, we keep the power, we put the power, and we decrease it by 1, so it's x to the power 1. Now what about 4 radical x? The derivative of 4 radical x, we keep the constant 4, and the derivative of radical x is 1 over 2 radical x. We directly use the property. So the derivative of radical x is 1 over 2 radical x, and the derivative of 8 is 0 because it's a constant. So finally we'll get minus 18x to the power 5 plus 14x, and we divide 4 by 2 to get 2 over radical x. Now according to the domain of definition of the function, domain of f is r plus, as I mentioned, x should be greater or equal to 0, so it is from 0 to plus infinity, while according to f prime its domain is r plus star, means the set of real positive numbers except 0, so without taking 0 into consideration, Why is that difference? Why is it here r plus and here r plus star? In that case, the radical is in the numerator. It is not in a denominator. So we don't have any problem if x is equal to 0. So we can take it as a condition. X here can be greater or equal to 0. While according to the derivative, the radical x is in the denominator. So we cannot put it as x greater or equal to 0 for the condition. We just have to put it as x greater than 0. That's why the interval is opened at 0 and we go till plus infinity. So as you notice here, the domain of the function, the domain of definition of f is from 0 till plus infinity, where it is closed at 0, while here it is from 0 to plus infinity, where it is opened at 0. It's not including 0.